In this lecture, we will do the application for vectors. Before we do that, I want to show you one more example. We know I is a unit vector on x, 1, 0. Okay, that's basically if you draw xy coordinate plane, you have here, this one is 1, 0, sharp one. And this one, j, is 0, 1. Okay, yeah, this one is I. Alright, now, what is these two vectors used for? You see, if we are given -2, 9, we know that's -2, 0 plus 0, 9. This is not a problem. If you pull 2 out, because 2 times 0 is still 0. So that's 1 times -2, it goes back. So it's the case here. 0 times 9 times 0 is 0, and then 9 times 1 is 9. Okay, here is not a dot, it's a comma. Now, here is 1, 0, so that's I. So you may write -2 times I plus 9, and here is j. So you may express this one like that. Okay, and this will be easy for us to do some addition and subtraction. For example, if A is 1, 4, I plus 4j, and B is 3i minus 2j, how to add? You see, you will do is what? There is a 1 in front of I, you add I with I. So that will be 1 plus 3. Yeah, 1 plus 3, you will get 4. 4 minus 2, you will get 2. So it's what? So it's 3i to j. And that's the final answer. Okay? And then you know, you may end up right here, but you also know that's basically what? 4, 2. Okay? So it's up to you. You may write either like this or like this. Alright. Now, let's look at the application. This one says that the airplane, so is in the airplane industry, is that with the airspeed of 400 miles per hour is flying in the direction 50 degrees, is, you see, here is the north. 50 degrees means like that, 50 degrees. And then wind, 40 miles per hour, wind is blowing directly from the west. So from the west to the east. So then, as shown in the figure. Okay, so the airplane goes like this. Probably I should use yeah, it should be clear. This one. This one. Okay. Now you know, if here is 50 degrees, here is the north, and here should be 40 degrees. Okay, because here is 90 degrees. If here is 50, here has to be 40. Okay. Now, the vector P can be represented. What's the vector P? You see the airplane is trying to go 50 degrees in this way. Okay, 50 degrees in this way. Probably I want to mark it with a different color. So probably I want to do is using the red one to mark it. So airplane is going to fly in this way. Okay? Now the wind goes this way. Okay? And if your airplane flies this way, the wind will blow the airplane with this vector, then the actual path will be what? I should use probably down here different color. Let me use a pen. So you see, this will be the final course for the airplane. All right. Now you see the vector theory tells us that the airplane tries to go into this red way, the red vector. And we know what's the speed? The speed is 400. Okay, 400. Now again, if here is 400, here is 40 degrees, then you know how long is this part. And you can see, let's assume this is x, okay? Then you have x over the red one. The red one is 400 miles per hour divided by cosine 40 degrees. Then you know if both sides times 400, then you cancel this one, so you then have an x. Okay, yeah. And then if you have an x, that will be 400 times cosine 40. Then you have an x, which is 400 times cosine 40. All right. Now, how about y down here? Y. How long is that? Y over 400 is sine 40 degrees. Okay? Then again, if both sides multiplied by 400, what do you get? You can cancel this 400 with this 400. So then you get y is 400 sine 40 degrees. So you see previously, then you can then have what? A vector which is 400 cosine 40 degrees, 400 sine 40 degrees. So this is x, this is y. Previously, you know, if you know x and y, then it can be written in this way. Negative 2i y j. So then this p vector can be written in this way. 400 cosine 40 I plus 400 sine 40 j. And this is a smart way when you use the vector theory. You may say, make things complicated. It's not really that case. You will see how easy when we use vector to solve this problem. Now, the wind goes from the west to the east. And you know, then the wind is just 40I because it goes this direction. Okay? Yeah. So there is no j because you can put j here. That's fine. That's what? 0 times j. Okay? So it's still 40I. Now, you then add those two together, you'll get the diagonal, right? Yeah, that's the theory. Okay, this is the real cos, the blue one. Then you add those two, you'll get the real cos. You see how easy it is for us to find out the real cos. And then when you add those two together, you add I with I. Okay, so 40 add on 400 cosine 40. So you have your x. And y is 0 here. 0 with sine 40 degrees. So that's 400 sine 40 degrees. That's j. Now, if you can find out the magnitude, that will be the ground speed. Okay? And how to find out? That will be this number squared plus this number squared. Choose the square root. Okay? Yeah. Before we do that, we want to find out 400 cosine 40 plus 40 is this number. 346.4177772 I. Sine 40 degrees times 400 is 257.1150439. Okay. Now you have the length. You have the length down here will be 346.418. You run this one. And then here is 257.115. Yeah. And then you squared both, add together, choose the square root as 431.41 miles per hour. Okay. So you can see previously it was 400. The airplane tried to fly. All right, now is what? Because of the wind. You save gas. You have 400. You got 31 miles per free. Okay. Okay. Faster. All right. We have figured out the ground speed. How about the true cos? What's the degree? Apparently, it's not 50 degrees anymore. It's bigger. So we want to figure out. Now, you know, this is the true, the blue one is the true cos. Then if we know the xy down here, we know the xy down here. And then, you know, right here, this is 346.418. That's x. That's x. And y is still this way. That's this way. Okay? So what? So if you have this original y divided by from this point up to this part, then you will have is tangent. You have is tangent theta. Okay? So let's say this angle is theta. Okay, let me put theta here. Theta. Okay? So theta is this one, so opposite side over adjacent is tangent. That's y, opposite side 257.115 over adjacent. That's x, 346.418. That's tangent theta. Wait, is that tangent theta? 257. That's y. Yeah, that's this one. Right, over this one. That's tangent theta. Yeah. Okay. Right, opposite side. Wait. 257. That's this one. Over 346. So what we get is this one. Yeah, y. Yeah, y over x is tangent theta. Yes, I was right. I was right. Yeah, this is this part. This is y. Okay. And then this 346 is this one. is, let me put 346.418 in this one. Okay, yeah. And then there's the theta, and the theta, tan theta. And then if you choose the inverse, you have a 36.583 degrees. Now, if this angle is theta, this true cos is this angle up to the blue line. So you use 90 degrees to minus theta, you have the true cos. True cos is 90 degrees minus that. Okay? And then you get 53.42 degrees. Okay, that's the application. I will see you next time.